Hello, it's Professor Stevens. I'm going to go through some examples for you that might help you working on a worksheet I've given you in class, and I'm hoping that you will come with it mostly completed. Even if it's wrong, just completion would be great. So I'll be checking for that, and I'm going to show you some similar concepts that you can try to translate to that worksheet. So we're doing restaurant orders here in this example. You can see I've got my two-way table already set up. You see that I'm using A for restaurant A, B for restaurant B, C for correct order, and W for a wrong order. We're going to find the probability of each of the following events, assuming that only one order will be randomly selected. In other words, n equals 1. Now, before we get started, it's a good idea to come up with your totals, which I did already. I'm going to just be revealing each cell. So I added up for restaurant A the 335 and the 30 to get 365. For restaurant B, same thing. Add up 277 plus 57 to get 334. Then to get the correct total, I would add up the 335 plus 277 in order to get 612, and then 87, and then the grand total, when you add up these two values and you add up these two values, you should get the same answer, which is the grand total, which is 699. Now, I actually got that 3 different ways just to show you, right? So I could add up all of these and get my grand total. I could also add up the two totals for the rows, the two row totals, right? Or I could add up the two column totals. And these are all, let me show you that again. The two column totals. So these are all different ways of coming up with n, but all three of those ways should give you the same number, and that's sometimes a good way to check if you set up your table correctly. This I already had set up for us, but sometimes you'll be given a paragraph and you'll have to sort out the numbers into the two-way table yourself. So this is just good practice to make sure everything is adding up as it should. It doesn't guarantee that your table is set up correctly, but it is one way to check and see if you need to rethink anything. Let's do number 1 here. It says we're going to find the probability, right, for all of these. Find the probability of each of the following events, assuming that only one order will be randomly selected. So number 1, a wrong order or an order from restaurant A. So the notation would look like the probability of W or A. And we would use the addition rule for this. The addition rule is that we're going to add up, that's what I meant today, I just gave away the answer, which I don't mind revealing that. The solution is 422 over 699. So how did I get that? So it says W or A. So using the addition rule, that means I'm going to add up the probability of W plus the probability of A, and then subtract the probability of any overlapping events. So that would be, to get the 422, I'll just show it over here. So we are going to add up, I'll highlight the ones I want to add up. So we're going to add up all of the wrong ones and any from A. Or actually, I just said A. I said wrong, but I meant all the ones. Can I start over? So first of all, just looking at the first part, W, wrong, all the wrong orders. And then A, all the A orders, right? Now the thing is that I actually highlighted this cell twice, right? So maybe I could do it this way. I hadn't really thought through how I was going to highlight this. Okay, so there's an intersecting part that gets counted twice, which is why you can either find the 422 by adding up each one individually like that, And you don't need the sum function for that either. You could have just done it like this plus this plus this, right? You can also do this plus this, right? Because those are the totals for A and W. But then you have to still subtract off the overlap. So you can see that this has 30 more than it's supposed to because I just used the column totals that time. So I would have to then also subtract the overlap. So it's two different ways of getting it. And then the answer, the actual answer, is the 422 divided by 699, which works out to be that, and then rounded to 3 significant digits, although I don't like those extra zeros. This is 3 significant digits right there. Now I am going to set this to 3 places only because 3 significant digits is 3 places for that one example, but in general you're going to need to round these by hand to make sure you get 3 significant digits and not necessarily just 3 decimal places. The next one says a wrong order from restaurant A. So wrong from restaurant A means that we have to find the intersection of restaurant W, of having a wrong order and being from restaurant A. So the overlap is the 30, and so we get the 30 out of 699 for that. There's your answer, which has a leading 0 after the decimal, so it'll be 0.0429 when you round it properly. Number 3, a wrong order given that it is from restaurant A. So we're starting off with the given assumption that this order is from restaurant A. Okay, what does that look like in notation? Wrong given A. Okay, now let's think through this. A wrong order given that it is from restaurant A. So I'm going to undo the formatting here. So all of the, I'm only allowed to consider right now these. These are the only ones that I can look at right now because I have the given assumption that I'm in restaurant A. Within restaurant A, I have the wrong order. The number of wrong orders, rather. So that's why I get 30 out of 365, which works out to be that, which is rounded to that. 3 significant digits. A wrong order given that it is wrong. This one's a silly, just for the purpose of thinking through it. Wrong given wrong? Well, we would only be interested in, let's see, all the wrong ones, all the wrong orders. We can only look at the wrong orders, and within the wrong orders, how many of those are wrong? All of them, right? So it'll be 87 out of 87, which turns out to be 1. A wrong order given that it is a correct order. Again, kind of a silly idea here, or a silly example. So now we're only going to look at the orders that are correct, or that's the wrong thing I want to look at. Correct orders here. And how many of those are wrong? Well, none of them are wrong, right? So the solution is 0 out of 612, which works out to be 0. Number 6, a wrong order from a restaurant A given that it's restaurant A. Okay. Okay, so it's a wrong order from restaurant A. That's the first event, the compound event, that it is a wrong order that's from restaurant A. But also given under the assumption that it's from restaurant A. So this is actually redundant, but we're going to do it anyways. So I have the first event noted here, wrong, and it's a wrong order in restaurant A, so there's an intersection there of the two events. and then also under the given assumption that it is restaurant A. So I'm going to be looking only with the given assumption here. I'm only going to be looking at all of the A orders. And within those, I want to find all the ones that are in the intersection of wrong and restaurant A. So wrong and restaurant A, right there. We've seen that one before. So actually a simpler way of saying that is just wrong and A, right? You turn, well, no, I meant to say this one, wrong given A. It's a shorter, this one is a shorter way of saying this. They mean the same thing. And you get the same answer. Okay. Alright, so the next one then, a wrong order from restaurant A, given that its order is wrong. So it looks like that. Again, the compound intersection being both from both a wrong order and from restaurant A at the same time in a single order, and also under the given assumption that the order is wrong. So it turns out to be looking only at the wrong orders. Let's first select only the wrong orders, and then how many of those are both wrong and in restaurant A. So that's why the answer is 30 out of 87. Now, there is a shorter way of saying this. A shorter way of saying that would be A given wrong, right? Restaurant A given that it's a wrong order, because you would do the same thing. You would look at how many are wrong, so that would be your denominator, 87 in the bottom, and then out of those, how many were in restaurant A. Okay, so that means the same thing. So the answer is this, which, oh, and I didn't tell you the rounded question. So for this one, the rounded answer, 3 significant digits, and for this one, 3 significant digits. So notice that this one is to 4 decimal places, but that is 3 significant digits, while this one rounded to 3 significant digits turns out to be also 3 decimal places. And then we can also do some with multiple events. Find the probability of each of the following events, assuming now that 2 orders will be randomly selected without replacements. So that's the change here. Okay, so 2 without replacement. So first of all, the probability of a wrong order and then a wrong order again in the second event. Wrong and then wrong. Shorthand way of writing it like this. And then I would want to multiply the probability of getting a wrong times the probability of getting a wrong, which I'll just show you the solution. So you can see that right here, this is the probability of getting a wrong order on the first try. So I select one order, and there's a total of 699 orders. 87 of them are wrong. I'm just going to clear this out. Okay, so what I was looking at is the total, 699. And out of that, how many were wrong? 87. And then for the second event, though, we're doing this without replacement. Therefore, I now only have 86 wrong orders out of a total of 698, one less on both of those. Right, so when you do the math, you multiply these, you'll get this answer, which rounds to 3 significant digits, like that. Then we have number 9, wrong and then correct. Wrong and then correct. So, it looks the same on the first try, but then on the second try this time we're showing the number of correct orders, which is 612. I had taken out a wrong order, so there's still a total of 612 correct orders left, and then the grand total has reduced by 1, so 698. And the the decimal answer and then the rounded answer. 10, wrong and then correct, given that they are both from restaurant A. Right, so that would mean that it would mean that every time that we do a selection, we're only going to be looking at, let me say it like this, we're only interested right now, we're focusing in on these, because they're both going to be from restaurant A. That's a given assumption, right? So in notation, it would look like on the first event, given that you're selecting from A, it's a wrong order. And then on the second event, given that it's from restaurant A, it's a correct order. So the solution looks like this. On the first selection, there are 365 that you can consider total for restaurant A, and only 30 of those were wrong. On the second try, you're reducing the grand total to 364. The number of correct orders in restaurant A is 335. It has not been reduced because previously we took out one of the 30 wrong answers. Right, so when you multiply those together, you get this, which rounds to this. And that's it. I hope it helps, and we're going to do those problems in the worksheet. Hopefully you will figure it out on your own and really impress me, and we can move on to doing more examples instead of staying on that example for a large portion of the class. So we'll see how it goes. I'm going to be checking for completion, so please do try to do these problems. Thanks. See you then.